Okay. Last class we had done Newton interpolation. I have uploaded the recorded session in CN. You can check. You can check for previous semester for the following chapters. Okay. Now Lagrange interpolation. Still interpolation, but using Lagrange method. My pen is not working. New haircut. Okay, so we start. Now, Lagrange is a reformulation of Newton that avoids computation divided difference. Now, Newton, it is Newton divided differences, which we divide the range. Okay, for Lagrange, Lagrange, this is the equation, the general equation. Okay, let me make it bigger. Now, Lagrange, this is the general equation of Lagrange. Same thing, you need to know what is your n, okay, and how many points that you need to have. Okay, what is the order and how many points. Now, Lagrange, just to recap, for Newton last time, it is, you need to find the B. Okay, this is Newton plus B3x power 3 plus Bn xn. Okay, up to here. Now, Lagrange, this is the general equation where you can see over here Li. Okay, Lix multiplied by Fxi. N is the order. I is the starting point. You should start from 0. Okay, X is your required value. Okay, this is the general form of Lagrange. When you are given, let's say, n equals to 2, n order. So you need to expand the equation. Let's say, where should I? Okay, let's say n equals to 2. Okay, so expand this equation. How to expand? F2x L 0 x F x 0. Okay, L1 x F x1 until n equals to 2. L2x Fx2. Okay, so you need to expand. Start from 0, L0 x. Okay, L1x, so L2x. Last time in Newton, we find B. Lagrange, we find the Lagrange function, the weighting function. Lix is the weighting function. Okay, that is Lagrange. Now, in Newton, we have specific equation to find the B. Same with Lagrange. Lagrange, we use this to find the L, value of the L. Okay, follow me closely. Now, this thing, make it bigger. Lix. N is the order. Now, J, there is I and J over here. Okay, this sign is the product of this thing. Okay, this is the general equation to find the L, the weighting function. X minus xj over xi minus xj. Now, let's say you want to find n equals to 2 just now. So, L not equals to x minus xj xi minus xj. Okay, now see, over here j equals to 0, meaning that j must start from 0. But j cannot be the same as I. Okay, j must start from 0, but j cannot be the same as I. Now, here is your I. Okay, so for L naught, j must start from 0, but j cannot be I. So here, our n just now is equals to 2. N equals to 2. Okay, so you should have L naught, L1, L2. Okay, now for L naught, x minus xj. J must start from 0, but j cannot be I. Okay, so here, this one cannot be x naught. Cannot. N2, you have how many points? 3 points, right? 3 points. So you must have the point. Your point is x naught, x1, x2, right? Okay, so here, xi is not x0 minus j suppose start from 0, but j cannot be 0. So this is not valid. You cannot use x naught because cannot be same as I. So for L naught over here, it should be the correct one. X minus x1. Okay, xi, x naught minus x1. Must start from 0. That means 0, 1, 2. But j cannot be same as I. Since here is 0, so j cannot be 0. So skip, move to x1. Okay. Then we have x2. We should include x2 as well. So x minus x2 over x naught. This one remain x naught minus x2. Okay, so this is the equation for L naught x. Okay, for L1, here, L1 x. X minus xj. J must start from 0. So here, x naught. Xi is 1. This is your I. So x1 minus x naught. Okay, so multiply. Because we have another point. X1. Cannot. Can. Cannot. J cannot be the same as I. Your I is 1. So here cannot be x1. Skip to x2. x1 minus x2. If you minus x1, down here will be 0. Then you will not get the value. Okay? For L2, we have until L2. So L2, x minus x naught. J must start from 0. but j cannot be the same as I. So here is x2 minus x0. X minus x1, x2 minus x1. Okay, take note this part should be the same. Okay, that is Lagrange method to find the weighting function, the L. Okay, different from Newton. The equation is different. So it doesn't matter if you have n until 3, you must include all the data points. L3, so if n3, you must find L3. Okay, that is the concept. Later we do the exercise. Okay, any question for here? Okay, just now I show n equals to 2. Now, if you have n equals to 1, same thing. But if n equals to 1, it's just involve x0 and x1, right? So that's why here your L0 only involve x0, x1. Okay, this is L0, this is L1. Okay. Okay, always remember this part. J must start from 0, but J cannot be the same as I. Okay, any question? Clear? Now, for second order, n equals to 2, as I mentioned just now, this part is the L. Okay, you can straight away put it in the general function, or you can find it one by one. This is L0, L1x. This is L2x. Okay. If third order, until L3. Okay, you must include all the data points. L3, we have x0, x1, x2, x3. Okay, so your L function must include all data points. It is not limited to this. Okay, you can see if your N2 only up to x2. If your N1, you only have x1. Okay, L2, L3 up to x3. Okay, so this is L0, L1, L2, and L3. Okay, so the derivation is the summation of all weighting function. Okay, summation. Then the Li here is the product of. Okay. Now let's try some example. This is from textbook. Okay, from textbook. It asks you to use Lagrange interpolating polynomial for first and second order to evaluate ln2 and the basis of the data given in the previous example. Okay, this one similar to the Newton example last time. Last time we need to find ln 2 using Newton. Now we try using Lagrange. First order and second order. So n equals to 1, n equals to 2. Okay, so we do one by one. First is n equals to 1. n equals to 1, how many data points? 2, right? So it involves 2 points, which is x0 and x1, fx0, fx1. Okay, which one you want to use? Which one is your data point? What is your x0 and x1? 1, 4. Can I use 1, 6? Why cannot? Can also. 2 points. So I can choose over here 1, 4 or 1, 6. 4, 6 cannot. Because ln 2, your x is 2. Your x is 2. Okay, so 2 is here. You can either use 1, 4 or 1 and 6. Your x must be in between your data points. Okay. So let's say I choose 1, 4. x1, x0 is 1, x1 is 4. Okay, so you have your fx0 and fx1 over here. Now, first step, identify your point. Okay, this is first step, your points. Second step, what is your function? The general function, okay? Lagrange, remember Lagrange. So Lagrange Lagrange, that is your general function for Lagrange. Okay, so since you have n equals to 1, okay, n equals to 1, here n equals to 1, okay, so here it should be the summation of the weighting function. Okay, then expand the function, which it will involve L0 x fx plus L1 x fx. N equals to 1. So your L should be until L1. Okay, so step 3, find your weighting function. L0. X minus x1, correct. Over x0 minus x1. Okay, find the value. Then your L1 x minus x0. x1 minus x0. Your x is now is 2. Okay, find out what is your L0 and L1. Why 2? Because the question asks you to find ln 2. Okay, evaluate ln 2. So that's why your x is 2. So what you get for L0? 0.6667, right? 0.333 for your L1. Okay, so once you get your L0, sub into the main equation. Okay, here, so you should be getting 0.46, is it? Ah, 0.46205. Okay, so this one equivalent to F12. Okay, proceed to n equals to 2. Okay, for n equals to 2, so your point would be 3 points. N equals to 2, you have 3 points. So your data point is this from the given. Yes, use all. Okay. Find the weighting function, the general function F22. Okay, so it will involve L0 until L2. Okay, find out your L for each. Let me know if you are not clear or if I go too fast. Please make sure you understand during the class. Okay, so most of you can understand the concept, but some of you still are confused. Okay, as I mentioned earlier, for L function, you must include all data points. Okay, L not, so X not, X minus X1, X not minus X1. Okay, do not stop until here. You must include X2 as well. Okay, so you remember the definition of the function, waiting function is product of. So you must start from 0. So from 0, 1, 2, 3 until n. Okay, so L1 include all the data points. Okay, once you get your L, sub into the main equation, you will get your final answer is okay, F2, 2. Now try to check the true error with n equals to 1 and n equals to 2. What you get? The true error. Sorry. Okay, try to find the true error. This one, true value last time is 0.6, what? 6932. 6932. Let's take 6932 lah. Okay, so find your true error for both data points, for both orders. So you can see when you have more data points, the error is lesser. Okay. This one just now, Julius, what you get the true error for n equals to 2? 18.49. N equals to 1? 33.3. 33.34. Okay, so when n equals to 1, 33 something, the error. But when n equals to 2, reduce to 18. So the more points that you have, the closer to your actual value, real value. Okay. Now we try this. Okay, this one, try to use both methods, Newton and Lagrange. Okay, this one, it already gives you the T and Z. Now, T, okay. Student, from this data point, you need to know which one is your X, which one is your Fx. Okay, don't get confused. So which one is your X? T. Okay. This is your X. This one is your Fx. Okay. Now the question asks you to find for A, Newton, using Newton to determine Z at T 2.5. So your X is here, 2.5. Okay. Use third order. Okay, for A, it doesn't mention what order. So just fix to n equals to 3 so that we can compare with the B. Okay, so try to do. Using third order, find y at t equals 2.5. Okay, this is your f3x. A Newton, B Lagrange. Try to do. How? Okay, for A, it doesn't mention regarding the order of the polynomial use. This one, since it doesn't mention, I fixed to n equals to 3, same as the B. Usually, the question will mention.
And you mentioned does need a default.
Okay, for A over here, it asks you, make sure that you order your points to attain the most accurate result. What do your result tell you regarding the order? So this one actually, it asks you to do increasing order so that you can see which order has more accurate answer. Yeah. So the higher the order, the accurate your answer, right? Yes. So we just pick n equal to 3. Now n equals to 3, you should have 4 data points. Now select your data points correctly. You must include 2.2 and 2.7. Entry 4 points. So I will advise 2.1 and 3. So 2.1 is your x0, 2.2 x1, 2.7 x2, this x3. Okay, try to do. A Newton, B Lagrange. Okay, in final exam, if you mix up, cannot get any marks.
If we use the different like actually like for 2.7 different values, different answer get the same.
Slightly different, but should be in the range. You can also take your data point from 2.2 to 3.4. So here you can have 3 sets of data points. The exact value is your fx, not fx1, fx2, fx3. If down your data points first, then expand to find your waiting function. Newton used B, Lagrange waiting function.
And use different. But the
In your CFO, one of it is interpolation. So it must come up. You have two interpolation, either one or both will come up. It's still the straightforward. Once you identify your data points, identify your equation, you can sub all the values.
installation. Yeah. That's really yeah, I think something like it. It's not really
Your data point or data point same ah. This one 17, I don't remember which data point that is. As long as your answer is in the range, then you should know whether your answer is correct or not. In the range here, I mean, yeah, your fx should be between this value. Okay. Okay, so this question you can have few sets of data points from x naught 2.1 and x 3. Okay, another set of data point you can have from 2 2.7. This one also can. Okay, or you can also have data points from 2.2 to 3.4. as long as 4 points and your x is in between the data points. Okay. Okay, so Newton, Lagrange, any question? Clear? Straightforward one. Numerical, if you know, you can score. Otherwise, or if you do it wrong method, that's the only issue. Okay. Wait, not finished yet? Just last question, I just want to explain. Later you can do at your own time. Okay, this one, textbook as well. Now, this question, it gives you the data set. Okay, calculate F4 using Newton of order 1 through 4 from this question. But this one, I just want to ask you. This is your data set. It asks you to calculate F4. Let's say n equals to 3, for example. Okay. Now, 3 we know 4 points. What is your x? 4. Zaidan, this question, what is your x? Huh? 4. Why you say 4? Huh? Because you have 4 points. Why you say 4? What? Sorry? Point F4. So your x 4. Yes, correct. Okay, so make sure you understand to find the info. Here is F4. So 4 is your x. Because while some students cannot get the concept. Okay, not all the time the question will straight away give you x equals to what. Sometimes it just gives something like this, F4. Or find Newton using cubic equation. So cubic n equals to what? 3 or 4 cubic. Cubic n equals to 3. Okay. Sometimes the question just asks you linear function. So linear means what? N equals to 1. Okay. Quadratic 2. Okay. Sometimes the question doesn't give straight away what is the order, what is the x. You need to find. Okay, so that's all for interpolation, Newton and Lagrange. Any question? Clear? Straightforward one. Okay, so next class, I will go to chapter 5. Okay, so that's all. Thank you.